Hello, teacher and classmates. We are going to continue with the topic estimation of a bioenergy system that provides biofuel to Ecuador. This time we are going to talk about estimation of the renewable resource, estimation of the renewable energy system, conclusion and recommendation. First of all, we are going to remember the objective of our project. The general objective is estimate a bioenergy system that provides biofuels to Ecuador. The specific objectives are calculate the technical potential of a bioenergy system to produce biodiesel and determine the location of a bioenergy system to produce biodiesel. At the beginning, we have two options for our project, and the palm oil and the sugar cane. With research, we found that the technology for produce biodiesel from palm oil is a mature technology, therefore a low cost of production. On the other hand, the sugarcane is a developing technology with a high cost of production. So we select the palm oil for our project. One way to produce biodiesel from the palm oil is the tank esterification process. This is a chemical reaction. First of all, we have vegetable oil like triglyceride plus methanol and a catalyst. The product of this reaction is a mixture of fatty ester plus glycerol. A strong base or a strong acid can be used as catalyst. At the industrial scale, sodium or potassium methanolate is used. The mixture of fatty ester is the biodiesel. Here we have the flowchart of a biodiesel processing plant. At the beginning we have methanol, oil and the catalyst getting in a reactor. The next step is the separator. Here we obtain the melty ester, and the next step is methanol removal. After the neutralization and washing, here we need additional products, acid and water, and the out product from this process is the wash water. Then we have dryer, and then we have the finished biodiesel. It's important to know that the glycerol leaving the separator is only about the 50% glycerol. It contains methanol, the catalyst and soap. In this form, the glycerol has a little value. So we need an additional process, the isolation and separation with acid, and we obtain 3 fatty acids. Then we have a methanol removal. And here we have glycerol. The methanol from these two steps getting in a methanol water rectification, and here we have methanol storage and the water. Also, animal fat and used cooking oil can be employed in the esterification process.
Okay, now we have the estimation of the renewable resource. It means the potential. First of all, we need to obtain the theoretical bioenergy potential. In this case, the theoretical or gross bioenergy potential of the agricultural and agroindustrial residues in the country is determined through the data provided by the Bioenergy Atlas of Ecuador, which considers the geographical distribution of production and waste generated by the cantons of the country's main crops in 2014, where there are maps, as we can see, that determine maps and tables that determine areas where the generation of African palm is concentrated, and mainly the table referring to production in Ecuador. So as we can see, we have, for example, that the surface the total surface of production is this value of hectares, and the most recently value of the energy potential is 87,000 of terajoules. Besides, we need to consider that this production is permanent through all the year. After that, we need to consider the sustainable bioenergy potential, which is based on the ecological criteria under which a fraction of the reduce must be left in the field to facilitate the proper functions of the ecosystems. It is worth mentioning that in the case of African palm requisition, the theoretical bioenergy potential and the sustainable bioenergy potential are the same. This is because since the African palm oil is not responsible for maintaining the ecosystem balance in the African palm plantations. To maintain this balance, we need the waste of the palm as leaves or the radish, but not the palm oil. Finally, we need to consider the technical bioenergy potential, which is directly linked to the technology to be used for the energy use of palm oil in Ecuador. In this case study, we are considering the typical technology, which is the transesterification process. We have one advantage that is all the technical potential is obtained directly from the ANCUPA, which is the National Association of Oil Palm Growers in Ecuador. With this value, we can multiply the total zone area and the biodiesel yield. So we can obtain amount of liters of biodiesel production in 1 year. To obtain the energy, we can multiply this for the typical calorific power of the biodiesel of palm oil, of the African palm. And we can obtain this value of energy, which is almost 50,000 of terajoules. But as we can see, after that, we want to consider our main data is going to be this amount of liters produced per year. As additionally, one of our objectives is determine the location of for a plant of production of biodiesel. For that, we need to consider that the main province producer of African palm is Esmeraldas. We can consider for that a data of a paper of the Central University and the most recently data of INEC. Additionally, we can consider that the Esmeralda refinery was used as the final destination of biofuels. It means that we need a refinery to produce the biodiesel. So as we can see, Esmeraldas is the province where is the most the main amount of palm oil, and in Esmeraldas it's the refinery. So the logical is that we for the location of a producer, a plant producer for that, it's gonna be Esmeraldas.
Hello, my name is Kevin. I am going to talk about the estimation of renewable energy system. For the estimation of renewable energy system, it's necessary know the potential of biodiesel, and the question for this case is not necessary note the total zoned area and the biodiesel yield. It should be note the total soil area of African palm. We use in the information the following table that show the total soil area of African palm is 240,333 hectares, and the yield of biodiesel 5,550 liters over hectares of cultivation. Then the biodiesel potential that can be obtained from African palm with this data that we are obtained from the most recently updates. This necessary note the biodiesel required for the transportation sector. I have the comparison the biodiesel potential cultivate with diesel consumption in the transportation sector. For this part, we need a focus on the year 2018, and it is necessary focus in the units, because if you remember, when I calculate the biodiesel potential, I calculate in liters, not in gallons. Is necessary to transform, and the diesel oils include the diesel for artisanal fishing. When I transform, the total liters of biodiesel consumption in the transportation sector is 3,823 millions, and the total liter of biodiesel calculate is 1,303 millions. It is important to note the amount of biodiesel consumption in transportation sector versus the amount of biodiesel production in Ecuador, because a comparison is made to see how much of the biodiesel production for African palm will be covered for the demand in the transport sector. For this, it has to barely cover with 33 4.88%. The 8% is it is small. Um, for if you want to supply of the biodiesel demand for the transportation sector in Ecuador, two solutions are proposed. The first solution is we remove a variables can be controlled and modify. In this case is the total sold area that is done to obtain a production of more liters of biodiesel. It is necessary calculate with the total liters of biodiesel consumed in the transportation sector for I know the missing area. When I clear the question, it is to know to the area that I will need to cultivate African palm to supply of demand. At the means the Ecuador will need of sowing area of 448,567 that the hectares I missing area for the abast of all demands. The biodiesel mixture with diesel. It is another alternative solution in the case that there is not possibility of having a larger sowing area, because for example, when you compare two components or two elements, it's necessary to know the characteristics, the composition, and etc. For this case, it's the same. The biodiesel has a great advantage because it is a my component is similar to number of cetane. Due to the similarity between the chemical structure of diesel fuels and biodiesel, they can be mixture in any proportion, but it is necessary, it gives better results, and it is considered an optimal solution when mixed the in proportions equal or greater than 2% of biodiesel. For this part, this presentation showed in this picture that the biodiesel from the African palm has a higher cetane number than the others. This is important of cetane because they increase the life of the engine. And the biodiesel mixture to supply demand. We see that not with a 50 mixture of the diesel and biodiesel, even so it is not covered with all demand, or cover 30%. For this part is necessary to recalculate for know the missing area need. A calculation is made to see how much the area is need to supply with this demand, and it has to be that missing area need is 104,117 hectares. This value it is smaller than the missing area, the first solution. So in my opinion is the best solution because only need less zoned area, and if you see for the environment point of view, it is not a pollution, and there is need to modify the engine and increase to life the engine, of course, for the number of butane, and it has the greater lubricant power. Thank you for attention.
Finally, the conclusions and recommendations. Our main conclusions, we can say that in the technical potential study was determined that the biodiesel production process produced approximately this amount of biodiesel. Besides, from the analysis of the technical potential, it was determined that the total production will cover almost the 35% of the total demand in the national transport sector. Another conclusion is from the analysis of the technical potential, it was determined that to cover the current demand for diesel, it's necessary this amount of hectares of African palm cultivation will be needed exclusively for oil production. The use of renewable energy increases over the time. In this case, there will be a greater demand for electric heavy-duty vehicles. This will produce a decrease in the amount of diesel needed to cover the national demand. In this scenario, it will be expected that the national demand could be covered by the total production of biodiesel. Almost the most important is that it's not possible to have a total dependence of biofuel to satisfy the national demand in the transport sector. As an optimal solution in the case of not having a sowing area of this amount, it will be necessary to mix the biodiesel with the diesel in a proportion of 50% in order to not lose the properties of the fuel and to have a good number of stands. For that, it is necessary to cultivation of this amount of hectares to supply all demand for diesel in the transport sector. The recommendations. Carry out energy studies considering the rest of energy sources such as sugarcane backsage, banana, rice, cocoa, etc. The carry out of feasibility studies on the transportation cost of African palm rackees for a centralized biodiesel production plant from the palm plantation. And finally, implement a process that improves the quality of the glycerol extracted from the biodiesel production process, so that it can be used in other applications or be reinserted in the biodiesel reduction process. Thank you for your attention.